Hey, you might have heard of this saying a bad MMM is actually worse than no MMM. And there's some truth to that. And there are various factors that go into that statement. But in this video, we'll look at just one of those aspects, which is multicollinearity. And specifically, we are going to look at VIF and how it actually works the hood, because I want to give you an intuition of how VIF actually works. And just to be completely sure, VIF stands for various inflation factor. Okay, let's actually begin with an example. Imagine you're running TV ads and a few other digital channels like Facebook, Google, and so on. And you run an MMM and you see that TV ads had the highest contribution and the digital channels did not have much contribution at all. Now you might think, okay, MMM is good now. Let me take action on it. And you cut down on all digital channels because they were not showing any contribution in your MMM. And that's where we might go wrong, especially if the model had high multicollinearity, which means one feature or variable or channel could be easily predicted by combination of other channels or variables or features. So in this case, when we increase TV spend, there's most likely that people will try and search for it on Google or respond well to Facebook ads and then come and purchase. But because we've killed completely our digital channels, we've just increased all of our budget into TV ads, then our sales kind of plummet. And then we are left scratching our heads thinking, what exactly happened? Why is RMM so wrong? And this is the exact situation that we want to avoid. And let's understand what VIF is and how we can use this tool so that we can make our MMM even better. So let's think of an example that is other than the marketing channel. Let's say you want to predict price of houses, right? And then you have a few features. Let's say you have the square feet of the house, number of bedrooms, and number of baths. Well, and usually what happens is you try to predict or build a model that predicts the price of the house. And here you typically go for R square, which is really high. And R squared just explains the amount of variance within this independent variable that is explained by all the other features or dependent variables. So in that case, we do want high R square. And this is where beginners kind of get stumped, because as we'll see in VIF, we actually want R squared to be as low as possible. So this is the normal modeling, right? So this is normal modeling where we're trying to predict the price and we use all the features and we want high R square. Now, when we look at VIF, what we're trying to do is kind of leave out price completely, and we're trying to see if one feature can be predicted by the other features. So let's take example square feet. So we want to see if square feet can be predicted by number of beds less number of baths. And when we do that, we usually get an R squared as well. And we want this R squared to be as low as possible. And the reason why is because VIF, the formula is 1 divided by 1 R squared. So you'll see the R squared is the denominator. So having a low value is good. So if we were to plot this out, so this is how it might look like. Let's say this is VIF in our x-axis. Let's say this is phi, this is 10, 20, and go up to infinity. And let's say this is a feature over here, square feet, and then this goes from 0 all the way up to 1. Let's say this is 0.9, 0.8. And if we were to plot the R squared over here, let's say we had 0.5 over here, and then 0.9, and then it goes up, right? So here we have this threshold at 0.8, which is phi, and then the 10 is somewhere around here. Well, you get the idea that this graph is not the best graph. Okay, I drew that one again. So at 0.9, we have 10 over here. And this curve is the R squared curve. So you'll see that as the R squared increases, the VIF goes up to infinity. That's why we were saying we want R squared over here, which is as low as possible. In other words, that means square feet over here cannot be easily predicted by bed and bath variables we have in a model. Now, you might have also seen when people talk about VIF, they also show you this kind of correlation matrix. And whenever I see a correlation matrix like this only gives half of the information. So even if we have a high correlated 0.9 over here, we still want to run VIF because this correlation matrix is just looking at one feature against the other one, so square feet against number of bathrooms. But when we do the VIF over here, we're looking at not just one-to-one correlation, but also how all the other features within the model can be used to predict the final feature, in this case, square feet. So we can easily extend this to marketing as well. Let's say we have TV spend, Facebook spend, Instagram spend, and then revenue. And we easily can predict the revenue based on all of these features. But if we run VIF against each other, how much of TV can be predicted by Facebook ads plus Instagram, and how much of Facebook ads can be predicted by TV ads and Instagram ads, and finally, how much of Instagram are predicted by TV and Facebook. And if you see, even if one of them has high R squared, and let's say this is 5, and then this is 0, and then maybe this is a 10. So this is the variable that we want to pay particular attention to, in this case, Instagram, because that can be easily explained by TV and Facebook. Phi is usually close to the middle of the threshold, so it's okay, but pay attention to it. 0 to 5 is anything that's still fine, and you can leave those variables in your model. So for just for argument's sake, let's say this was also 10. Facebook and Instagram both say they are 10. And what do we do next? So there are a few things that you can do to fix your features that you have here. And we saw this in one of my previous videos as well. And there are many, many things that you can do, from entry level to the really advanced stuff. So one of the basic things here is you can just get rid of Instagram over here and then just run it on TV and Facebook. And granted, we are losing more information here because we're not adding RAM, but hey, that's one of the downsides, because these are highly correlated, and maybe the next time we run it, we can run a few incrementality tests or geotest or do some triangulations to sort of see what kind of results we are actually getting from Instagram. But with MMM, there's no way we can include this and get a good read for our MMM. So that's one way. The other way is maybe you just combine all this into another feature. Let's say this is digital, right? So you can just have TV ads plus digital and then see if you can build your MMM in the revenue. So this is another way of trying to solve this. Now, again, you're bundling more channels into this digital channel now, so you're not getting that granularity that you would like from your MMM. But hopefully by doing this for this digital, you'll see that VIF might go down. I mean, the R squared for the entire model, let's say here in this case where you did have multicollinearity, you were getting 0.5 for R squared, you might get 0.85. But then the VIF for each of the channels is 5 or less than 5, which means you can trust this model a slightly more than what you got here, even with high R squared. There are a few other techniques which requires kind of its own videos on it. So there's PCA that you can do, principal component analysis. Again, you lose some information here. There's also regularization that you can do. Something like a ridge regression has L2 regularization built into it, or there's also L1 regularization. So with L2, you kind of have more stable coefficients, so they're all coming close together. With L1, some of those coefficients can go to 0. So if you have like 15 channels and you're not spending equally among them and you are cool with dropping a few of these channels, you can go with L1, play around with that. Or if you want best of both worlds, you can also go with Elastic Net. And if you're feeling a bit more confident and you have a really good hierarchy, let's say you have the awareness channels at the top of the funnel, and then you have consideration and then buying. So it's like a funnel over here. Then you can go for residualization, which is kind of an advanced way of trying to solve this. But if you're planning to spend millions of dollars, then you probably might want to invest more time into solving all these things so that you get some better results, so you can take good business decisions. So that's VIF in a nutshell, even though the video was longer, but hopefully you have a good understanding of how VIF works and how the R squared that we look at within VIF is different to the R squared that we get from the usual modeling, and why we want the R squared within VIF to be as low as possible. So to sum it up, VIF, we are trying to predict one feature or one channel if you consider MMM using all the other channels. And that's all it is. Try and remember that. And I do have a guide on this as well, which goes in depth into all these simple examples, math, and on, so that you have some resource that you can read and try to understand yourself. So if you need this, drop a comment or go into the community on School and you'll have access. So until next time.